Okay, so this was asked in 2011. It was asked more recently on a mock paper where instead of B and C we had from A to B, but it was the same question and the solutions done out the same. It's a question about circles, so I'm going to write down first of all the area of a circle just to have that ready. So this is in our formula book. So the area of a circle is pi times the radius squared. And then I'm going to put in the two radii of the big and the little circle. So the big circle starts at the center and we go to the point B, and that's capital R, so that's the radius of the big circle. And then the second radii, the one of the inner circle, the small circle, I'm going to call small r. So you need to use two different letters there for the radius because they're different sizes and we can't use the same letter if it's not the same size. The last thing I'm going to fill in is the distance from B to C is 2x, and so from B halfway is going to be x. So the key to a question like this, where there's very little information on the diagram but there is information in the question, is to fill in as much stuff as you can. We weren't told either of the radii of the small circle or the big circle, so we just have to create something for them. Like, could we have said that this was y and this was z? We could, but because it's radius we may as well just use r. So capital R and small r are the same as saying y and z, so we're going to use r's. Now the area of the shaded region is the area of the outer circle minus the area of the inner circle. So the area of the shaded region, and this is how we would do this question if we had been given the actual numbers of the radii instead of just capital R and R that we've made up. But we would find the area of the larger one, which is pi capital R squared, that's the area of a circle, the larger one is capital R radius, minus the area of the smaller circle, which is pi r squared with small r. Now that's fine, I mean that's the answer to this part of the question, what is the area of the shaded region, but that's not in terms of x. What we have there is, we have an area in terms of capital R and small r, so we need to work with this so that we can somehow have only x's in the answer, and that's kind of tricky to kind of see how are we going to get rid of the capital R and the small r and just have x's in the question. Well, what I'm going to do is I'm going to write down Pythagoras theorem over here because I can see a right angle triangle. So Pythagoras theorem says that c squared equals a squared plus b squared. Let's redraw that right angle triangle just so we can see which one I'm talking about. So it's the one where the hypotenuse is capital R, we have r here, and we have this as x. And so just to fill in the numbers and see what happens, because sometimes that's what we're going to do. Like, we might not be immediately sure about the direction that we're taking, but if we have to try something, I can see a right angle triangle, and oftentimes that is the first step to try Pythagoras theorem. So I'm going to put in that capital R squared is equal to x squared plus small r squared. And so then I come over here and I see that I have this capital R squared, and I'm asking myself, well, I can replace that r squared, can I replace that with this? R squared, capital R squared, is x squared plus small r squared. So let's replace it and write down x squared plus r squared. And then let's have minus pi r squared. And then if we expand the brackets here, we have pi times x squared is pi x squared, and pi times r squared is pi r squared, then minus the pi r squared. And then all of a sudden it becomes apparent as to what the solution is going to be. The pi r squared cancels with the minus pi r squared, and we have that the area of the shaded region is equal to pi x squared. And then just make sure to write down units squared. If it was centimeters, we'd say centimeters squared. Whatever the units might be, area is expressed as the unit squared. Okay, so that's the first part of the question. The second part of this question is tricky, and let's see what we're being asked first of all. So in the case where the radius of the outer circle is 2x, so let's fill in 2x here. So the radius of the outer circle, we're going to say is 2x. They're saying in that case, show that the portion of the shaded region that lies below BC has an area of 2 pi over 3 minus root 3 on x squared. So let's color it in light blue. So we're being asked to show that this light blue region below BC has this area given here. Now, how do we find that? Well, let's write down the following. So we'll do it in light blue. So the area of that region is going to be equal to, and we'll get a couple of different colors here just to highlight. So let's put red. So the area of the sector, so the sector is from B up to O, down to C, and then down here. So I was coloring that whole sector. A sector is a piece of a circle, and we'll see how much of that circle it is in a minute, but that whole region there, if I was to color that in, and let's just do a couple of colors. So that whole region there, if I was to take that and subtract from it the area of a triangle, so if I minus from that the area of this triangle here, so the triangle BOC, so the area of triangle BOC. So that's the first step. Just decide on what you're actually trying to find, and then we can assign some formulas to this. So the area of that light blue region is going to be equal to the area of a sector. Now there's two formulas for the area of a sector. There is the formula when we're using radian measure, which is half r squared theta. So that's the formula for the area of a sector if we're going to use radian measure. But we'll just use degrees in this question and see if we can get to it. So from our junior cert, we'll remember that the formula for the area of a circle is pi r squared. And then the area of a sector is the fraction of the circle that you have. So where theta is the angle BOC, and then what fraction is that of 360 degrees, a full circle. So we'll just, maybe with the orange here, we have a little angle up here. We have to try and find that in a second, and that's our theta. Okay, and then from that we're going to subtract the area of the triangle. The area of a triangle is half AB, where A and B are the two sides, so in this case OB and OC, which are both 2x, by the sine of the angle between them, so the sine of C. And again, that C is that orange bit that I've colored in, and we're going to find that in a second. So I'm going to park this for a second till we go and we find that angle. So this theta is equal to the angle C. We have to go and find that. So how are we going to find that? Well, let's go back to our right angle triangle that we had in part 1. So I'm going to draw it again like this. And the bottom was X. And the side here we had as, we don't need this. I mean, we had it as small r before, but we're not going to need it in this question. And the hypotenuse is 2x. And what we're trying to find is, we're trying to find this angle up here. Now, the angle theta, or the angle C that we want, is double this angle, because there's one on the left triangle that looks like this, and a symmetrical one on the right hand side. But let's just go and find that angle first. Now, how do we find that angle? Well, we're going to use a trig ratio. So we're going to label the sides. If this is the angle we're trying to find, well then x is the opposite side, and 2x obviously is the hypotenuse. So the ratio we're going to use is sine. So that's the ratio that associates or gives the ratio of the opposite to the hypotenuse. So the sine of that angle, let's call it, let's just call it x, because, no, we're not going to call it x because we have little x in the question. Let's just call it y. Okay, so the sine of y, and I'll tell you why we don't call it theta in a second, but the sine of y is equal to the opposite over the hypotenuse, so x over 2x. Well, x over 2x is a half, so sine of y equals a half. And then we have that the sine of y is equal to 30 degrees. So sine of y is equal to 30 degrees. The reason that we didn't call it theta is, well, remember, theta is twice that angle. So theta is equal to 230 degrees. Theta is equal to 60 degrees. Okay, so let's see if we have enough information now to fill in and get this answer that we're looking for, which is 2 pi over 3 minus root 3 over x squared, or on x squared. So pi r squared is pi. Now the sector, the radius of the sector, the red sector, is 2x. And that's going to be squared. So 2x by 2x. And then theta, our angle, is 60 degrees. So that orange angle up here is 60 degrees. So that's 60 over 360, which we'll change to a sixth in a second. And then the triangle is a half. AB are the two sides, so again that's 2x by 2x, and then by the sine of 60 degrees. Okay, Okay, so let's tidy it up. So we have 2x by 2x is 4x squared times the pi, and then 60 over 360 is a sixth. We'll do something else with that in a second. And then minus 2x by 2x is 4x squared, half 4x squared is 2x squared. And the sine of 60, if we throw that into the calculator, is root 3 over 2. So root 3 over 2. Now the rest of this question is just trying to tidy this to what we were given up here initially. So let's see, can we go and do that? So 4 times a sixth is 2/3, so it's 2/3 x squared pi minus, and I can see that this 2 and this 2 can cancel, and I get root 3x squared. Have a look up at what we're trying to show, and we can see that they've factored out the x squared. So if we factor out the x squared from the first term, we get 2/3 pi in the bracket, minus factor out the x squared from minus root 3x squared, and we get minus root 3. And then we're just going to make it look like they had it, so x squared just goes at the end. So it's 2 over 3 pi minus root 3 inside the bracket, and that's all multiplied by x squared as required. So often these questions, you know, that have circles in them, just one of the keys is to spot that there are right angle triangles in there, where we can use those right angle triangles to find ratios and missing angles. There is other ways to do this question as well. That's probably the most straightforward.